Hello, hello. It's me, Krishna Pokhrel. I'm here to explain about the oscillator experiment which we will perform in the physics laboratory related to the field electronics. So, I want to say something about the practical of oscillator. Okay, the word oscillator here describes about the thing that uh, here the oscillator refers to that material, that type of electronic device which convert DC to AC. Okay, direct current will be converted to alternating current with the help of oscillator. Okay, we are talking about such type of oscillator over here. So the experimental diagram of oscillator is mentioned over here. Okay, I want to go through that diagram, how to connect this oscillator and what type of voltage gain will be there in this oscillator, how many times the voltage gain is possible with this Wein bridge. Okay, it is the first type of oscillator, Wein bridge, and the second type we'll discuss here about the phase shift oscillator. So um, at first we need this operational amplifier, so it is possible with the help of 741 IC. Okay, which have an inbuilt amp operational amplifier over there. So what we will do is we will connect a resistance R1 10 kilo ohm. Okay, this R1 resistance 10 kilo ohm will connect to the negative terminal of this operational amplifier. That means this amplifier have four legs each in its part. Okay, 4 legs in each part. So we know how to count that. There is a little bit small mark, dot mark on that IC. So this one is 1, 2, 3, 4. By this way, we have a numbering. And here, similarly, 5, 6, 7, 8. The numbering goes in such way. So what we will do is we'll connect this 10 kilo ohm resistance, one terminal to ground and other terminal to the negative point, that is the number 2 number of this 741. I see this 2 number point will be connected with this. Now before that connection, we can just we need to join one variable resistance, that is called a potential meter. Okay, potential meter is there, some it is an electronic device which is available in laboratory. We'll connect that potential meter over here. Okay, from here to the other point, that is the terminal number 6. This is the terminal number 6, which is the output of our operational amplifier. So we'll connect here one potential meter. I have written a potential divider, potential meter, whose value is 100 kilo ohm. Okay, 100 k potential meter will be connected over here. It is the variable resistance. We'll connect here 10 kilo ohm, and this connection goes to the output terminal of op amp, that is number 6. Here is the number 6. We'll connect this RF, one terminal of this potential meter to 2 and other terminal of potential meter to 6. Potential meter have 3 wire connected with it. Okay, so we can take any 2 wire, first, second, or second, third. We need to include second, but we can take first, second, or second, third. We can connect it from 2 to 6. So this is the connection from here to here, and we'll check the output voltage from here. And again, from this 6 terminal, we'll connect 1 kilo ohm resistor R and 0.1 microfarad capacitor C. The value for the code for this capacitor is 104. Okay, I'll write here 104 is the code for this capacitor. 104 is the code for the capacitor of 0.1 microfarad. Okay, 0.1 microfarad capacitor can be connected over there. Okay, so again, we'll connect that capacitor to the third terminal of that op amp here, third terminal, and other one is from that same capacitor. We can break down into 2 parallel circuit. in one side we can keep resistor, 1 kilo ohm resistor, and connect it to the ground. Other side we can connect a capacitor, same capacitor, 0.1 microfarad, and connect it to the ground. Here I want to describe something. This is R and this is R. So the value of R should be same, 1 kilo ohm, 1 kilo ohm, and the value of C should be same, 0.1 microfarad, 0.1 microfarad. And the one thing here is we need to keep the value of R1 and RF in such a way that if we divide RF by R, if we divide RF by R1, then it should not be it should not be less than 3. Okay, it should not be less than 3. That means the maximum amount of resistance here which can be added is around 30 to 32, 33, whatever. If we divide, because here is 100, if we divide 100 by something, whatever value we want to keep here, the value should not exceed, should not be less than 3, because the gain of such type of Wein bridge is 3, which is in order of that we need to fix this RF and R1. I repeat once the same thing. If you divide, this RF is constant, that is 100k. So here if we take 30, suppose 33s are 90, but it is 33s are 90. We have some value 3 point something, so that is okay. But it should not be less than 3. It should not be less than, it can be more than 3. Okay, it can be equal to 3, but we don't prefer such type of thing. It should be greater than 3 because its voltage gain is 3. This is some little bit trick to understand to make our practical easy. Okay, so our all connections are clear. One thing I forgot to say, in this op-amp, this 7 number and this 4 number, which you can see here, 7 number and 4 number, this 7 number will be given positive BCC of 12 volt, and this 4 number will be given minus BCC of 12 volt. Here, in a 12 volt, such type of DC output, we have 3 terminal. One is plus, another is minus, and the middle one is ground. Okay, this positive one will be connected to 7 number terminal, negative one will be connected to 4 number terminal, and this will be common point as a ground. Okay, which will fix it in the breadboard. Okay, now we have its gain is 3, that is we can get the voltage gain from here, 1 plus RF by R1, that will be equal to 3. It is the experimental, it is a theoretical value. So from here we will take out the curve of B output, and from here we'll take out the curve of B input. In an oscilloscope, we'll connect this 2 point with the 2 probe. Okay, there is 2 probe in oscillator. One probe will be connected with B in, other probe will be connected to B out. So after that, what happens is we can see input voltage and output voltage over there, and we can just find out what is the gain. Whatever voltage calculation is easy in oscilloscope. Suppose the rise, amplitude, if you calculate the amplitude of a wave, such wave, the amplitude of such wave is known as a voltage. Okay, if we keep this in a oscillator, if we can see such type of wave in an oscillator, we can take all the total amplitude, not only we cannot see only amplitude. Amplitude is from here, so we can take this total value from crest to trough. Okay, the altitude from total crest to trough, such value is known as voltage. We can just see at what point the oscilloscope is kept, and we can divide that 5 division is this much voltage, and something division is that much voltage. By that way we can take out. Okay, another part is what we need to do now. We need to take out the value of B in and B out in at least for at least 3 different values of R and C. We need to change this R. Okay, one time we may keep 1 kilo ohm on both sides and see the curve, what will be the gain. Another time we can change it to 2.2 kilo ohm because it is easily available, 2.2 kilo ohm. we have a color code for 2.2 kilo ohm as a red. Okay, such type of resistance can be kept here because the value is RR. We need to change this to the equal value 1 kilo ohm for one value, 2 kilo ohm for other value, and 3.3 kilo ohm or something for the other value. And once we can change this capacitor also, I'll say why to change this value to see the gain. Okay, here we what we have done till now is we'll connect this circuit, we'll see the graph of input and output wave, and we will discuss our result. What will be the output and ratio of output to input, that is the gain. Gains will be nearby about to 3. If it is little bit more or less, we need to calculate the error through error analysis. Now the frequency to be measured over here, this frequency can be measured with the formula 1 by 2 pi RC. This R and C value will be this one, whatever we keep it over here, this R and C. For an example, for 1 kilo ohm, we can keep 2 pi into 1 kilo ohm into C, that is 0.1 microfarad, and calculate the value of frequency. This is theoretical frequency. And the experimental frequency can be taken out by whenever we kept 1 kilo ohm resistor, and we'll see the output curve, and we need to take out the time period. That means the distance between these two is a time period. Through our oscilloscope, we need to take out a time period. And if we divide that, we'll get a frequency. Okay. But it is not so much easy that whenever we connect, it will be ready. Everything will be ready. It is not so. The main thing to be done is after this connection, we need to check this potential divider. We need to rotate it very slightly and very much with a very much concentration. Okay. If there is no any concentration, then we may lose our data. So with the careful experiment, we can take out this value. And after that only we can see both wave. Okay, otherwise the wave will be half and the students may get trouble. So these things will be understood. And another thing is waves will be in phase, same phase. Whatever the input wave is supplied, the output wave and input wave will be in same phase. There should not be any kind of phase difference between these two things. So I hope it is clear about this Wein bridge oscillator. Here we have supplied DC voltage, but whenever we see this 3 number and 6 number terminal as an input and output, we can see a waveform in oscilloscope. It means that DC voltage has been changed by this device into AC voltage from this terminal 3 and from this terminal 6. Okay, with the help of this capacitor and all this DC will be converted into AC. Okay, and we'll take out a gain from here. Gain should be about 3 times, and for each and every value of resistance, we'll take out the frequency, and this theoretical frequency and experimental frequency should be very much near with each other. Why we change the value of R? Because the frequency depends upon R, and we don't have such type of more capacitor value to be changed. So we usually keep 0.1 microfarad and we change the value of frequency. If you wish, you may change this capacitor and try once again. What will be the gain? What will be the frequency? This we need to study with the help of this oscillator. Okay, for this we need a IC of 741. So with this much, I would like to stop saying further in this video. Okay, if you feel this video is good for the knowledge, so you may comment here. You may give a reply to me through any kind of thing, because I will share this video to my friends, those who need it. Okay, so you may reply to me. How do you feel, and what type of things should be improved here? What should be included? Okay, thank you very much.